Okay, hello again. Sorry for the technical problems. Okay. Uh, yeah, hopefully people saw the Discord and moved. Anyway, so going back, problem K. Okay, what do you need to do for problem K? Well, since you need to move at most once, um, what does that mean? Well, you effectively have two options. If you started at the top row, then the score you're gonna get is going to be some prefix of this top row and then some suffix of this bottom row. Okay, and then it depends exactly where you switch, right? But it's gonna be one of those. Or you start at the bottom row, so it's gonna be a prefix of the bottom, then a suffix at the top. Okay, and then the question now is, what's the optimal position to swap? You don't know that. So the best strategy to solve this problem is just try all the possible ways that you can swap. Okay? So for those who got the idea and actually even know how to code this, my tricky part yung problem, which is it's possible na your path is just completely go through the top row or completely go through the bottom row. Kasi sabi naman at most once. Doesn't say exactly once. So you're free to go actually not switch at all. So these are possible answers as well. So you have to take that into account. Okay, but that's the easy part. Okay, this is the hard part. You need to try all possible where you can swap from one row to the other. Tapos anong gagawin mo? Well, let's say you're at a position, you're trying, what's the answer if I swapped at position pos? Then what do you need to do? You need to get the sum of everyone in the bottom up to pos. And then you need to get the sum of everyone at the top from pos onwards. Okay, and then you do a similar logic for the other case where you start at the top row. Okay, so let's see how to code that in a simple way first. Okay. So there's a comment from Red Gold Crown saying, I got stuck at figuring out which was the best place to switch. Okay, so yeah. So as far as we know, yung numbers na yan are random. You probably have no smart way of knowing in advance where you're supposed to switch. Kung entirely random yan, you know, there's probably no smart thing you can do that tells you this is the exact point where you have to switch. So this is why we have a computer. We let the computer. What does a computer allow us to do? It allows us to try doing lots of computations, try lots of possibilities one by one, and then get the best one. Okay? So that's what we're gonna do. We're gonna brute force essentially. Okay, so let me read the input as before. Okay, let me switch to the code. So let's read the input. Tapos, top row. And then, what do I want? Let me take care of the case where I completely go through the top row or the bottom row already. So it's going to be max sum of top row or sum of the bottom row if I don't switch at all. Okay, but I might switch. So that's not necessarily the best answer. So what do I do? Where do I switch? I can switch in all possible positions. Let's say from 1 to n minus 1. Right? Tapos, what do I want to do? I have two options, right? I can either top first, then bottom, bottom first, then top. Kung nandito kayo sa stream ko nung round 0 or round 1, I explained na helpful ito so that hindi kayo masyadong nag-struggle mag-code. Try to break down what you want to implement in bigger chunks first, and then okay lang kahit English, write down what you want to do in English in comments so that you progress writing your program bit by bit, not thinking about all the details all at once. Okay, so that's what I'm in my head. The high level idea is I'm gonna try all positions. Tapos for every position, I have two options. Either I'm gonna start at the top, up to this position, and then swap this bottom, or start at the bottom, up to this position, swap, then top. Right? So paano yun? So more specifically, that means I want the sum of top up to index pos. Okay, and including pos. And then plus sum of bottom up to starting from pos plus 1. Say up to the end. Right? Tapos yung bottom first, ganun din. What is this? Sum of pot up to index pos. Inclusive. Tapos, well, there are many ways to do this. I won't show the complete code for how to do this anymore because you guys probably know how to do this, right? How to get the sum of numbers from the left side of the array up to a certain position, and how to get the sum from the right side from a certain position up to the end. And then you just do this. Ans equals max ans of whatever this is, right? And then same here. The problem with brute force is It's slow, right? Let's try to analyze what's happening here. So in this top loop, you're doing n steps. Tapos, what happens down here? Well, if you do it naively, how would you do it? You would go like top 0 plus top 1 plus top 2 plus top 3 up to top boss, right? Tapos, would go plus bot boss plus 1, bot boss plus 2, up to n. How long does that take? Or how many operations do you need to do this sum here? Okay. Actually, it doesn't even depend on pos. You will always need to do n operations to compute this sum if you do it one by one. Same thing for down here. You need to do n operations to compute this one by one. Okay. I'm not actually sure if I'm still connected. Hopefully I still am. You guys can tell me if something's wrong and then you don't see me. I might be disconnected already. Okay, I think I'm connected again. Okay, sorry. I don't know what's up with my internet connection today. Medyo malas lang. My internet connection is normally fine. Just so happens to be bad today. If there's something that you feel like I skipped and you want me to go over again, just tell me in the chat. Okay, pero anyway, I was saying is up here, you need to do n steps to do this loop, and then within each iteration of that loop, you're gonna get a sum, and to get that sum, you also need exactly n steps for this one. This one requires n steps. Tapos, this one at the bottom is also n steps. So in total, this means you're actually doing something like 2n times n steps. Or in big O notation, we would say that you're doing n squared steps. And what is n this problem? How big can n be? Well, n is up to 10 to the 5. So that means n squared is up to 10 to the 10. That's too big. What do we know? We know that a computer can do roughly 10 to the 8 Python operations, or actually 10 to the 7 Python operations per second. So that's definitely too slow. We need maybe 1000 seconds in the worst case to wait for this to finish. Okay, so hindi pwedeng sobrang brute force. So minsan, kailangan natin maging smart. Okay, but we don't want to be extremely smart. Ano ibig sabihin ng extremely smart? Extremely smart is find the smart way to figure out ano yung index exactly kung saan ka magsaswap. Pero in the absence of extra information, you don't really know that. You can't be that smart. And if you try to do that, you risk getting wrong answer. So we're gonna try to be smart in a different way. What are we gonna do? We're still gonna try all the positions to guarantee that we tried all the possibilities and we can't get a wrong answer. In other words, I'm not going to try to optimize this loop away. Instead, it seems more reasonable to try to optimize this one. Okay, so ito yung tip ko for today. If you have a solution and it's too slow, how do you find the faster solution? Well, the first thing you need to do is analyze. Where exactly is the slowness coming from? So like here, we broke it down. Yung n squared na yan, actually, it's because there's an n up here and there's an n down here. And then you need to decide which one feels easier to get rid of, or which one feels easier to optimize away. This one feels harder kasi optimizing this away means meron kang magic something that lets you know exactly which position you have to swap. But that seems too magical. Ito less magical kasi ano to, this is just computing sums. And then maybe there's a smarter way to compute these sums. Okay? How do we do that? So let's think about it. Let's go here. Kunwari, ito yung list ko. 3, 1, 4, 1, 5, 9. What do I want in this problem? I want, ganito diba, ang gagawin ko, sum up to here, tapos ganyan, yung bottom. Tapos, sum up to here, tapos yung baba. Tapos, sum up to here, tapos yung bottom row, and so on. Right? So, let's ignore the bottom row first. Wag muna yan. Let's think about just how do we get the top row sums. And let's use this example. Okay, so can you tell me what's the sum up to this point? The sum up to this point, it's easy, right? It's just 3. Tapos, what's the sum up to this point? Well, it's 4. What's the sum up to this point? Well, it's 8. And then 9. And then 14. And then 23. How did I get this answer quickly? Do you really need to add them all again, one by one, to know that this answer is 23 down here? Okay. Think about it. How do we get these sums fast? Paano ko alam agad na 23 yan? And then if I add more, okay, I know this is immediately I know this is 25. You can tell, right? This is 31. And you can tell this is 36. How do you know that? Did you add all of these one by one? No, right? How do I know this is 36? Well, I already know that the sum up to this point is 31. So, instead of going through all of the numbers again to get their sum, to know the sum up to this point, since I already know the sum up to the previous position, I can just keep that. And then all I need to do in this single step when I move from pos to pos plus 1, all I need to do is add a single number. And that's way, way faster than just adding them all again one by one. Right? Okay. Hopefully gets you yung idea. Yes. Okay, I'm reading the comments now. And yes, that's right. You can eat away all of those numbers because you can keep the sum so far, right? You don't need to repeat computations that you've already done before. Okay, so that's a tip. How do you become faster? How do you make a computation faster? Well, one simple way is don't repeat computations that you've already done before. Okay? If you can figure out the answer from a previous answer that you've already computed, just get it from that answer. Don't repeat the computations. Okay? Tapos, well, yung bottom row, ganun din yung itsura. Pero, what's the difference? How do we deal with the bottom row? Any ideas? Well, so top row, di ba, we're adding one thing at a time. Tapos, to get the sum up to here, what do? I get the sum of everyone, and then just add these two. Right? Well, so bottom row, what's happening? Well, as I move forward, let's say this is the sum from pos up to the end. What's the sum of pos plus 1 up to the end? Well, again, this is almost this, except for this guy. So you don't have to loop through all of them if you know this guy. Right? So I won't explain in detail, but I think you guys could figure it out, right? What's the difference between this guy and this guy? How do you get the sum from pos plus 1 onwards if you already know pos? The sum from pos onwards. Okay, and also, of course, you have to do something different at the start. For the top row, we can start with 0, that's easy. But for the bottom row, right, you have to start with something else because it's not 0 at the start, right? Yes, exactly. So Walsh and red gold crown got it exactly. You can subtract one by one. Okay. Sige. I think to keep the stream shorter, I won't show how to code it yet in this stream. I'll just give you guys notes later on so that you can refer to something. If you're really stuck, you don't know how to write the implementation for this, you can look at the code. But I think it's a good exercise to try to figure out how to program this yourself first. Okay, and it's really not that hard, so give it a try. Okay, I seem to have gotten disconnected again. My stream's still running. Okay. Sorry for the interruptions. Hopefully, I really hope that the recording is not broken. I'll check it later. And there's nothing important that got dropped. But, oh well. So let's go to problem D. So what's different in problem D now? Okay, problem D is much harder. Kasi, what happens in problem D? The scenario is still the same. You have two rows. You have the top and the bottom. But what can happen in problem D? You're allowed to swap at most k times. And this time, itong k can be any number, any arbitrary number from 0 to n. So, that means medyo mas mahirap kasi yung path mo can be weird. It can be this, like this, tapos ganyan. Right? It can be something weird like this, where you change in a lot of places. Okay, how do we solve this? Well, paano nga ba? How do we even get started? Well, the way to get started, a lot of times, is you try to come up with a brute force first. But this time the brute force isn't so obvious kasi there's so many possibilities. How do you even go through all of them? Right? And the thing you want to write in the end is some kind of loop, right? Or some kind of recursion, some kind of program. Pero for that to work, ano ba ang loop or recursion? Paano mag-develop ng algorithm? that has some kind of loop or recursion in it? Well, you need to figure out what is repeating in the process that you're trying to do, or what is similar. What is that one step in the process that you can say you are doing over and over, and therefore you can compress into a loop and turn it into an algorithm? Okay, what are we doing in this problem? Well, you walk sometime, tapos you swap. And then you walk sometime, and then you swap. And then you walk, and then you swap. So, ang path natin, ganito itsura. Walk, then swap, then walk, and then swap. Walk and swap. Aha, ito yung umuulit. We repeatedly walk and swap, right? And then we try to make sure that yung swap is at most k. So kung nag-swap na tayo isang beses dito, this means down here, we should try to swap at most k minus 1. And then try to swap at most k minus 2. Okay, so we have some kind of counter that tells us that we can use in a repetitive loop or recursion. Okay, what's happening here? The path, okay, here's the thing you have to see. A valid path through this, these two rows is a path with at most k swaps is you stay on the same row, stay, and then this guy is a path with at most k minus 1 swaps. Okay, do you see that? I want the best path that uses k swaps. Okay, a path with k swaps is going to look like this. It's going to start by walking straight in the same row, and then make a path with at most k minus 1 swaps. Okay, if I do swap. Okay, what does this suggest? Okay, this suggests we can express what we want with some kind of recursive algorithm. Okay, so there are some ideas in the chat saying, wait, try to subtract the top from the bottom and prioritize where to switch from there. That might work, but you have to be careful. That's not guaranteed to be correct. I didn't think it through, but my feeling is that it's wrong. Maybe it's right, but you know, it's something you have to prove. It's not obviously correct. You have to be a bit doubtful about solutions like this. Yung solutions na yan ay tinatawag na greedy solutions, which you might remember from a previous stream. Greedy solutions means you try to maximize your path by getting the most out of every step. Okay, anong problema dyan? What can go wrong? with a solution like that? Well, it's possible that it's possible that you waste your swaps on some useless things. For example, um, well, I didn't actually think this through, so maybe it's right, but I'm not sure. Uh, we can do this as an exercise later. Okay, here's my worry. My worry is you swap too many times at the start, and then at the end you don't have enough swaps left, and you were supposed to swap there. It was better to swap there, okay, or something like that, or uh, yeah, something like that. Okay, so yeah, let's do this later in Discord. Um, let's figure out if the greedy solution is actually right or not, and then if it's not right, let's try to find an example and understand why exactly it's not right. Okay. Okay, but for now, what do I want to do here? I want to show you a solution that is guaranteed to work, and you don't need to think very hard about why it's correct, because it's basically brute force. And we know brute force is nice because brute force is always correct. Okay, the only problem is brute force is slow. But we learned from problem K that there's a way to deal with brute force. There's a way to make a solution faster, even though it's brute force. And the way to do that is to not repeat computations that you've done before. So that's a spoiler for what's about to happen. But yeah, that's the plan. Okay, greedy. Maybe it works, maybe it doesn't. Let's figure out later. But for now, what do I want to do? I want to be sure. Be sure the answer is correct. And how do I do that? Brute force, but it's too slow. So the idea is try to reuse old computations. This is something we learned from problem K. Okay, but first, let's find out, how do I even try to brute force this? Okay, so let's go back. Ito yung thought process ko. Okay, the best path with at most K swaps has to be some walk without swaps plus the best path with at most K minus 1 swaps. And well, where do we swap? What position do we swap and do the best path with at most K minus 1 swap? Or don't swap at all. Right, that's another possibility. But if you do swap, then you do that swap, and then you definitely have to get the best path out of K minus 1 steps for the remaining. Because if you don't do that, then you can improve your answer by doing that, right? And then you get the best path for k steps. Okay, and then there are two different ways to start. Best path, starting at top row, means you walk the top row without swaps, and then do the best path starting at the bottom row with at most k minus 1 swaps. Or if you started at the bottom, it means you're going to walk the top row. You're going to walk the bottom row some number of steps without swapping. And then you're going to swap. And then this time you want to find the best path with k minus 1 swaps, assuming you start at the top instead. Okay, and of course, there's still the possibility that you don't swap at all. But we can deal with that later. So is everyone convinced that this actually tries all possibilities? And this will definitely give the correct answer. Assuming you code it right, this will always give the correct answer. Okay, what am I really saying here? What I'm saying is, best path, where you start from the top, and then k swaps, is you either step once and then k minus 1, or you step twice and then k minus 1, or you step 3 times and then k minus 1. Steps at the bottom. Okay, do you see what's happening here? We're effectively trying all the paths. If we do this, what's gonna happen here? Down here, this is gonna try 1, and then k minus 2, right? And then try 2, and then k minus 2, and then try 3, and then k minus 3. K minus 2 still. And then here, what's gonna happen? 2 steps, tapos 1, tapos k minus 2, tapos 2 steps, tapos 2 ulit, tapos k minus 2. Do you see what's happening? Okay, do you guys see what's happening? If you unroll this process, you will get all the possible ways. Okay, let me temporarily hide this so that you can see the whole thing. If you unroll this, you will get all the ways. Does everyone see that? Yes. Okay, great. Everyone sees that. Okay, now let's see. How do you code this?